So we have started the unit number 2. In that, the contents, once again we will just go through it, and from that today we are going to learn, that is the center tap full wave control rectifier and fully controlled bridge rectifier. So already you are having the history of knowledge of about this rectifier, that is what is center tap, what is a bridge rectifier, then what is the difference between that one, old one, and this new one, that only we are supposed to learn today. And in next session we will go for that, the diac and triacs applications. Okay, so these 2 points today we are going to cover in this session. So before that, just one question I'm want from the answer, that is what the from your side. So this is the simple question I asked. So if anyone has noted down, if anyone has gone through the PPT of last session, so you can give the answer for this question. So for half wave control rectifier, what is the formula for VO, that is output voltage, average output voltage? So if anyone has noted down, if anyone is remembering, or if anyone is knowing, so please mention in the chat box. 1 minute we will give, so that we will go ahead. Okay, I got the answer. So let us go with the next one, that is, so this is what the VO is equal to Vm by 2 2 pi in the bracket 1 plus cos alpha. So where Vm it is nothing but peak voltage and alpha is nothing but the firing angle. So what firing angle it is? So when the SCR will get on, that angle from 0 to that particular alpha, so that will be counted as a firing angle, and that is very important in a controlled rectifier. That is only the difference between uncontrolled rectifier and controlled rectifier. If you are using our normal diodes, so that will be treated as uncontrolled rectifier, and if you are using this SCR, that will become the controlled rectifier. That is the only change. But what is the effect on the output waveform or the working? That let us we will see in today's session by assuming the resistive load, because load is also affecting on that the respective functioning of that respective diagram or the circuit. So here you can see in the slide, that is the single phase center tapped full wave controlled rectifier. So the diagram is look like the same one, that is the our whatever we have learned in the earlier, but only we have replaced the normal diodes by the SCR. So two SCRs, SCR1 and SCR2, are been connected as shown in the this particular diagram, and the center tap it has been there with the transformer, which is air filled, which is has the 1:2 turns ratio. So what is this 1:2 indicates? So you might be aware of that. That is the number of turns at primary level and number of turns at secondary level. So that is the ratio it has. That is step up transformer. It is here. As the number of turns on the secondary, it is more. That is double. So it is known as that the step up transformer. Plus, if you can observe that the location and the position and the direction of SCR, so that is also important. And additionally, how the SCRB becomes on and how it is going to be get fired. So two SCRs are being used, and the basic property of any SCR is it should be in forward bias, plus the gate trigger has to give, so that that SCR will become on. Is it? So accordingly, you're supposed to just check out the waveforms which are shown besides to that diagram, and the waveform across each element, it is been shown over here. So Vs it is nothing but source voltage. So definitely, even though it is shown here the positive and negative, but it is not exactly the positive negative. It is a AC source which contains the positive half cycle and negative half cycle. Okay. So this is the Vs, how it look like. So that is the first waveform it is being shown, which shows that the we're supposed to concentrate on a one cycle only so that we can explain in a better way. So first waveform is the Vs. Second one, it is shown the VO, output voltage. That is the voltage across the load resistor. So how it come, we will discuss. Then the third one, that is ISCR1, means current flowing through the SCR1. Then current flowing through SCR2. And then the total current in the secondary, IS, that is the secondary current. And last one, that is the VSCR1, that is the voltage across the SCR1, like this. Now how it is going to work and why it is called a controlled rectifier. So as it is used the single phase, so single phase, the name it has been given. It is a center tapped, so the name center tapped. And the full wave controlled, this is the additional word it has been added due to this SCR. So when ISCR1, what is this? This is nothing but when the SCR is getting gate current. So that is at position of alpha. So 0 to alpha, nothing is there. If you are looking for the output voltage, 0 to alpha, 0 voltage. Alpha to pi, output you are getting. Again, this pi to pi plus alpha, 0 output. After that, pi plus alpha to 2 pi, you will get the output. So why it is that one? The steps are there. The simple one, that is when the SCR1 will be in on condition and when SCR2 will be in on condition. Accordingly, these pulses you will get or you will generate, and when these pulses are getting generated, so you will get the respective output across the SCRs. VSCR1 and ISCR1. So that will be nearly same. Only the difference is the current will be less as the voltage or the current drop will be there across the load. So that is what ISCR1 and the VSCR1. So that is going to be, we can compare. So what are the steps behind that? So during the positive half cycle of the input voltage, that is input source, SCR1 will be forward bias. So when this is plus and minus here, so this SCR1 will be in a forward bias, but it is not on. It is only in forward bias. At the same time, the SCR2 will be in reverse bias. So as it is in a reverse bias, there is no question of turning on. Is it? So this is what the first step. If we apply the gate signal, that is the gate current, if you are applying at SCR1, it turns on. So at that time, what is the time duration? Because we know that the x-axis, it is for the time axis, and omega t, it is nothing but angular time. So that's why we are counting it in terms of the angle. So alpha is the angle at which the SCR is going to be turned on. Alpha is the angle at which the SCR is going to be turned on. So this SCR1 will get turned on. At pi, when the current through SCR1 becomes 0. So at pi, so let us see here. So this is the position of pi. That is when the current is getting 0. So definitely it goes in a reverse bias. And as we have given only the trigger for gate, so that SCR will goes in a off condition. SCR1 will goes in a off condition. So output will be definitely 0. After that, that is it turns off normal naturally. During this negative half cycle, because after the positive half cycle, negative half cycle starts, and SCR2 now becomes forward bias, and SCR2 is fired at pi plus alpha. So after this duration, at alpha means alpha is the fixed angle or fixed time after which gate pulses we are giving to both the SCR1 as well as SCR2. So this is what we will get, and the output is also the same. We will get from pi plus alpha to 2 pi, up to 2 pi. So this is the what explanation up to the one cycle, that is up to 2 pi. And the same process is going to be continue till further the next one. That is the SCR1 will be on, at the same time SCR2 will be off for positive half cycle. For negative half cycle, SCR1 will be off and SCR2 will be on. So this is what it is going to be happen, and the respective output you will get. Now in this case, the average voltage, that is the, so definitely the rectifier, what is the main function? Convert AC into DC. So that average DC voltage, it gives with this respective formula, that is VO average is equal to Vm by pi into 1 plus cos alpha. Same terminology is there, how this particular formula is generated. So accordingly, yesterday only we have seen for the half wave rectifier in the last session. So in the same way, this is going to be happen, that is the sine of omega t. So this will be present for alpha to pi. So that values it has been taken over here, and the this final expression comes, that is Vm by pi in bracket 1 plus cos alpha. So with this we will get the average voltage or the average output voltage. Probably it will be a DC voltage we will get from this center tapped controlled rectifier. Now you will say, where is that controlled word comes? So the working of this particular alpha angle, if you will see here, so this angle is approximately 45 degree. This alpha angle is at 45 degree. You can increase this angle up to the 90 degree, up to the 180 degree, or less to the 0 degree. So 0 degree means what? It will get fire from the starting point only. If alpha is equal to 0, the full this positive half cycle you will get across the output load. Is it? Yes. And if you are increasing this alpha, so that time you will get the less output voltage. That is, depending on this value of alpha, your output will depends. That is, you can control the output. Ultimately, the intention is you can control the output voltage, and this is what the alpha, that is the angle it is going to be, decides when this SCR will get turned on and the output will be appear across the output load resistor. So this is what the this SCR1 and SCR2 in terms of the center tapped, it is going to work with resistive load definitely. Now similarly, the next one, or this the important, just a summary of this one, that is for the center tap transformer rectifier, T1 is forward biased when Vs is positive, T2 is forward biased when Vs is negative, but each will not conduct until it receives the gate signal. पॉझिटिव्ह हाफ सायकल मध्ये SCR1 ऑन असतो, निगेटिव्ह हाफ सायकल मध्ये SCR2 ऑन असतो, परंतु त्यांना जोपर्यंत गेट सिग्नल किंवा गेट ट्रिगर मिळत नाही तोपर्यंत ते ऑन होत नाहीत. सो दिस इज व्हॉट द summary it has been mentioned over here about this SCR. So this is all about center tapped full wave controlled rectifier. Next to that, that is this in the same similar fashion, it is single phase fully controlled bridge rectifier. Now the question or the this new words comes, that is fully controlled. So what is this mean by the meaning of fully controlled? So partially controlled or the half controlled and the fully controlled. So these two words are there. So first we will just see the fully controlled, and then I will tell that what is the difference between this particular fully controlled and the half controlled or the partially controlled. So as it is the only single phase is been used, because we are now dealing with power electronics. So power electronics, it comes with the single phase or the three phase. So in coming units, we have to face the three phase also. So the concept of single phase and three phase, that is star delta connection. So all we have to learn in detail. So you're supposed to go through it as a prerequisite, so that whenever we are going to study, so that will be easy to understand. So here this is the setup for single phase fully controlled bridge rectifier with resistive load. So if you are just changing or adding the inductor here in series with resistor, so that will become the inductive load. If you will add the capacitor, so that will become the capacitive load. But generally for the explanation, for our simplicity, we are just assuming that this is the resistive load we have connected across the output. So what is the its scenario? As our normal bridge rectifier with normal diode we have learned, we are remembering the same thing here, just replace all the diodes by the SCRs. So 4 normal diodes are being replaced by the 4 SCRs. SCR 1, 2, 3, 4. So besides to that, the waveforms are also shown. So the similarly, the as we have seen for the last point, the same waveforms you can observe over here. So first waveform is for the VS. So again here the VS is nothing but the sinusoidal signal AC source. Second waveform is for the output voltage, that is VO. Third one, it is the I1 comma I4. So what is this I1 and I4? So they are the gate current, that is I1 and the I4. Something it is missed out in this diagram. So I1 and I4 means here, if you are able to see the cursor, SCR4, that is this I4. So this diagram it is wrongly, so please just take a note and accordingly you just check it out. So it is I4. So I1 comma I4, then I2 comma I3, I2 comma I3, and the last one, that is the IO, that is the current across the output. So that is going to be shown over here. So our main work is the above 4 waveforms only, that is this the input and the output, and how this output is going to be changed. So it depends on this respective current pulses, which makes that the SCR on or off. So you might be aware that this is a setup for bridge rectifier. So two diodes or the two SCRs here are going to be worked simultaneously, and the other two will be in a off condition. So when or we assume that this is the what the position they have given for the positive half cycle, that is this one, upper terminal is positive and the lower terminal is the negative. So with this we can see that how this the or which SCR will becomes the forward bias and which goes in a reverse bias. So with this the positive and the negative terminology, SCR1 and SCR4 are going in a forward bias. I am saying forward bias, not the on. So they will be in a forward bias. At the same time, the SCR2 and SCR3 will be in a reverse bias. So when they will get on, when they will get the current pulse. So I1 and I4. This SCR1 and SCR4, both the SCR should get at the same time the current pulse, so that this particular configuration or the output will be having the appropriate output. So the firing angle alpha will be same for the I1 SCR1 and the SCR4, and this is what it is been shown here. That is, at angle alpha, the I1 and I4 will be get this two SCRs will get the current pulse, and these SCRs will become on. That is, the current is going to be flow through this SCR1 and SCR4. So this is what they have shown the current pulse. It will flow up to the pi because the basic condition is forward bias. And another one, till what time it will be in on condition? Till it is the in forward bias. But at pi, the input voltage is becoming 0. So as soon as it becomes the 0, so SCR1 and SCR4 will goes in a reverse bias and they will become off. So what the output voltage you will get? So it is shown over here. So see the cursor, I am just making it out. So this is what the output you will get. Now the negative half cycle is going to start, and that time, if you're making this negative and this is positive, so the SCR1 is becoming the reverse bias, and this particular it goes, the SCR4 is also going to be become a reverse bias. So this negative now the positive. So SCR2 and SCR3 are becoming the forward bias, and to them we have given the current pulse, that is I2 comma I3. So again the same angle, and this at same moment this SCR2 and SCR3 are going to start or become the on, and once they become on, the current will flow through them and the respective output we will get. That is, output follows the input. Output voltage will be similar to that of input voltage. So if you will see here, even though it is in a negative cycle is going on, we will get the this particular positive half cycle like that, the output across this particular R. Because whatever the directions are there, whatever the input voltage are there, but the current is flowing in the same direction through this R. So that's why whatever the output voltage will be there, so it will have no impact of this negative half cycle. It will just look like the whatever it was there for positive half cycle. But here one thing we supposed to assume that this alpha will be the same for positive half cycle as well as for negative half cycle. Due to that, the same this envelope we can observe in this particular output waveform. So this is what the I1 I4, that is at angle this is gone, and as I told, the output voltage and output current, it is also uh, up to the 90% it is same. Only whatever the voltage drop across that resistor it goes, or current drop appears across that resistor, that gets minimized. Otherwise current is also following the voltage, and this is what the final current VO and IO both are same. Exactly, the if you are looking for the amplitude, so the current amplitude will be a little bit less. That is, if VO is 1 volt, so I will be the less than that of the, as compared to 1 volt, it will be less than the that one. That is, with the scale with reference to this particular voltage, it will be less. So these are the waveform explanation and the explanation for this controlled bridge rectifier with the resistive load. So if you are writing in the working of this one, so in this circuit, diagonally opposite pairs of SCR get turned on and off together, that is simultaneously. The average DC voltage can be controlled from 0 to its maximum value by varying the firing angle. This is a very important sentence, की जे DC आउटपुट व्होल्टेज आहे ते आपण 0 पासून मॅक्झिमम पर्यंत व्हॅरी करू शकतो बाय चेंजिंग द फायरिंग अँगल. द SCRs आर कंट्रोल्ड अँड फायर इन पेअर्स. म्हणजे हे जे पेअरिंग आहे SCR1 आणि SCR4, त्याचबरोबर SCR2 आणि SCR3, so at a time they should be get fired, that is with the current pulse of that particular SCRs and with a delay angle of alpha. हा जो टाइम पिरियड आहे की किती टायमिंग नंतर ही आपण करंट पल्स देतोय, त्याच्यानुसार इट विल बी हॅव्हिंग इफेक्ट ऑन द आउटपुट व्होल्टेज. And the average output voltage formula, so you can observe, as it is the full wave rectifier, the last one was also the full wave rectifier, so the average output voltage will be the same, and that is nothing but Vm by pi bracket 1 plus cos of alpha. So this is what the average voltage is going to be remain same in the case of this center tap and the bridge rectifier. Now we will just skip that the point, that is the meaning of fully controlled. What is the meaning of this fully controlled? So in the coming slide, we will see that what is the meaning of, or the difference between fully controlled and the partially or the half controlled. So about this one, so important sentence, the delay angle is nothing but the angle or the time interval between the forward biasing of SCR and the gate signal application. कारण तुमचं AC इनपुट दिलं ते पॉझिटिव्ह निगेटिव्ह असतं. मग ज्यावेळेस पॉझिटिव्ह हाफ सायकल येते त्यावेळेस तो SCR फॉरवर्ड बायस होतो, परंतु ऑन होत नाही. मग ज्यावेळेस गेट करंट आपण देतो त्यावेळेस तो ऑन होतो. मग हा जो टाइम पिरियड आहे, दॅट टाइम पिरियड इट इज नथिंग बट द डिले अँगल. पुढचं वाक्य इम्पॉर्टंट दॅन द फर्स्ट वन. इफ द डिले अँगल इज 0, म्हणजे झिरो मोमेंटलाच जर तुम्ही फायर केला, त्याच वेळेस जर गेट करंट अप्लाय केला, तर दिस रेक्टिफायर विल बिहेव एक्झॅक्टली ॲज द युअर नॉर्मल रेक्टिफायर. नॉर्मल रेक्टिफायर मीन्स द अनकंट्रोल्ड रेक्टिफायर विथ डायोड्स. म्हणजे आपण जे डायोड वापरून रेक्टिफायर शिकलेलो आहोत, तर इट विल वर्क इन द सेम फॅशन. सो दिस इज व्हेरी इम्पॉर्टंट. केव्हा? ज्यावेळेस फायरिंग अँगल 0 असेल तेव्हा. So this sentence is just make it highlight because it might come in the MCQs or in the interview times also they can ask question की कुठलाही कंट्रोल्ड रेक्टिफायर नॉर्मल रेक्टिफायर सारखा वापरायचा असेल तर काय करणार तुम्ही. मग एखादं उत्तर देईल की हां SCR काढा आणि डायोड लावा. That is the solution. But without disturbing to that respective components, how we can achieve that one? So the answer is just reducing the firing angle. Reducing the firing angle, we will get this particular output as that of the normal diode. So this sentence is very important as far as this particular controlled rectifier is going to be relate. Now we will discuss about this one, that is the fully controlled and half controlled. So just observe the diagrams for this half controlled bridge rectifier and the earlier this fully controlled bridge rectifier. So you can observe that is the number of components, that is half control and full control. See this one, 99% the diagram is the same, but only replace any two of the SCRs, not any two, in a respective manner only, that is from a loop any one, because any one we cannot replace, but a respective from each loop the one SCR we can replace it by the normal diode, that is 2 SCR and 2 diodes. So this is known as the half controlled bridge rectifier. The working is the same one, the output waveform is also the same one, but here few changes in the explanation. So what is this particular change in the explanation? So it is nothing but the having the impact of gate current. So if you are looking for the gate current, that is for, as the two SCRs are there, so we have to give the gate current to the these two SCRs only and not for the D1 and D2. So when the positive half cycle will be there, so SCR1 and D2 will be in forward bias, is it? That is the current is going to be flow through SCR1, through load and through D2. At the same time, as obvious that the SCR2 and D1 is going to be in reverse bias. But as the current is going to be flow, only SCR1 it is in getting forward bias. The answer is no. It has to wait till the gate current IG1 will be received. So when the IG1, this current, it will be get received by SCR1. So that time only the current is going to be flow in whatever the direction I told right now. That is SCR1, load and D2. And the opposite is also there. That is for negative half cycle, the SCR2, load and D1. In this flow only the current is going to have a direction. The working will be the same, the output is also we will get the same, only the difference is it is known as the half controlled bridge rectifier. Got it? The waveform is also the same, only the change in the hardware it is been done in this respective half controlled bridge rectifier, and you will get the controlled rectifier. So this is what the setup for the we have seen for central tapped controlled rectifier and the full wave bridge controlled bridge rectifier. So this hub controlled, it is not mentioned in the syllabus, but so, as it is mentioned the fully controlled. So that's why we should know that what is meant by the hub controlled or the partially controlled. So that's why this point we have added over here. So in addition to that, if you want any much information about that, so you can refer the book also for this hub controlled bridge rectifier and it's a waveforms. So this is what for today's session we have planned. So if any query from the this unit or the earlier unit, you can still we are having the 10 minutes, so you can just asks. So I hope you all are here. Can I just check out today? We will conduct the attendance here. Other teachers, Akshas is also taking online attendance. So let us today we will check how many students are here. So if no questions are there, I will just take the attendance so that once we will verify randomly. Roll number 1, are you there? Roll number 1. So all students are requested to just unmute yourself and give the attendance. So as I see that roll number 1 itself, it is not available there. Is it the case? Roll number 1. Okay. Next one, you can just unmute yourself and give the attendance or utter your roll number.
2,
Okay. Next.
3,
Next. Roll number 4. Sonali, are you there? Okay. Fine.
5,
Hmm. Next.
6, 7,
Next. Okay.
8, 9, 10, 11,
Okay.
12, 12,
13. 13 is absent. Next.
14,
Next. Roll number 15. Komal, are you there? No. Okay. Next. Roll number 17.
Yes, sir. Roll number 7.
Okay. Okay. Okay.
18, 19,
Ne-
20. 20 is present, sir.
Okay. Okay. I heard. 21. Pratiksha, where are you? Next.
22,
22. Okay.
23,
Next.
24,
Next.
25,
Next. 26. Anjali, are you there? So those who have given the attendance, you can leave. No issue. So go for the next lecture. 26. Are you there? Anjali? No. Next.
27, 28,
Next. 29. 30.
30,
Hmm.
31,
Okay. 32. Next.
33, 33,
Thir- 34.
34.
अक्षय आणि अजून कोण?
36.
35 is there?
Yes, sir.
Okay. Ha. 37.
36. 37.
Okay.
38.
Okay.
39.
Okay.
40,
Next.
41.
Next.
42,
Next.
43,
Next.
44.
Next.
45,
Next.
46,
Okay.
47.
48,
Next. Next.
48,
14. 49. Absent.
50,
Okay.
51,
51. Okay. Dhanraj.
52,
Okay. Next.
53,
Okay. 54 absent.
55,
Okay.
56,
Next.
56,
Okay. Next. 57. Sanket. 57. Okay. Next. 58.
59,
Okay. 61. 60. Absent.
61,
Okay. You are there. Fine. Next. Kaushik. 62. Two is also absent, not present. Not absent, not present. Okay. 63.
yes sir,
Next.
64,
Next.
65,
65. Can you unmute for a while?
yes sir,
सुरुवातीचे बरेच लेक्चर तुम्ही absent होतात.
सर ती मोबाईलचा प्रॉब्लेम होता ऍबसेंट होतो.
तसं मग सांगायचं
आता
असतं,
रेग्युलर करतो सर.
मेसेज टाकायचा असतो.
सर माझा मोबाईल ठरवला होता हो.
बरं, ठीक आहे. ओके. नेक्स्ट. 66.
Yes sir,
नेक्स्ट.
67,
ओके.
68,
ओके.
69,
ओके.
70,
ओके. मंगेश. Then next. 71.
72,
71. Pawan, are you there? Okay. Okay. Fine.
The roll number
72.
4.
Roll number 4. Where you was, madam? When I asked.
सर तुम्ही रोल कॉल केला त्यावेळेस ऐक म्हणजे हेडफोन काढलेला त्यामुळे माझा नंबर देईपर्यंत पुढचा नंबर चालला.
बर. ओके मॅडम. ठीक आहे. ठीक आहे. काय हरकत नाही मॅडम.
हा, सर.
21 ऑल्सो. तुमचा काय प्रॉब्लेम होता मॅडम?
अनम्यूट होत नव्हतं.
अरे तुम्ही नवीन आहेत का मोबाईल हँडल करायला? दररोज वापरता ना तुम्ही लेक्चरला वगैरे. अनम्यूट कसं होत नाही मॅडम?
सर
मग
26.
प्रॉब्लेम झालता.
21, 26.
सर 1.
Okay. 1 I made it, madam. No issue. Anyone else? 13, 16, 29, 49, 54, 57.
yes sir,
Who is there? 54.
54,
ओके. मग ज्यावेळेस अटेंडन्स यावेळेस आजच घेतली मी, कधी नव्हते आणि तुम्ही गायब राहता. 16 also. अरे अटेंड करत जावा, लक्ष देत जावा, be attentive in the session. Okay, this is request from my side. For every subject, every session, you're supposed to be in the session only. Okay, anyone else? You just put in chat box and you can leave now. Thank you.